Hello, welcome all to our Gyan Academy channel. So, as you remember, last time we were discussing about the electric charges and the field. We also discussed about the superposition principle. We started doing few numericals, but due to time constraint, we could not complete much. So, today we will be moving further. We will start with the problem which we already did in last class. हमने थोड़ा एक पार्ट किया था, दो पार्ट उसके अभी बाकी हैं. We will try to discuss that. And along with that, we will also try to discuss few numericals which are very important from competition point of view. So let's start. So if you remember, this was the numerical which we were having. So we did the first part of it. पिछली बार हमने किया था कि इलेक्ट्रिक फील्ड इंटेंसिटी ड्यूज टू दिस टू चार्जेस प्लस क्यू एंड माइनस क्यू एट ए. मैंने इसे 1 कह दिया और इसे 2 कह दिया. Now if we are to calculate electric field intensity at B, so what I need to do is I need to bring a test charge which is plus Q at point B. So this charge 1, it will exert a force onto my test charge in this direction. So I can say my electric field intensity due to charge 1 at B, it will be in this direction. अब अगर मुझे इलेक्ट्रिक फील्ड इंटेंसिटी देखना है ड्यू टू चार्ज 2 at point B, तो अगेन आई विल ब्रिंग माय टेस्ट चार्ज विच विल बी पॉजिटिव इन मैग्नीट्यूड एंड इफ इट विल बी पॉजिटिव इन मैग्नीट्यूड. और अगर मैं देखूं दिस चार्ज, the test charge due to second charge, it will be attracted in this direction. So this will be my electric field intensity due to charge 2 at point B. So now if I go back to my superposition principle, my net force which will be acting or the net electric field at B, it will be equivalent to electric field due to 1 at B minus electric field due to second at B. So I know what will be this. It will be K times the charge, it is Q, this one, this Q, divided by the distance between this charge and point B, which is 0.05, the whole square, plus, it will be minus K times. And now we will not be taking this minus Q into consideration because we have already included minus sign here. We have already taken it in the direction. It will be K times, and this is Q divided by, so it will be this complete distance. So it is 1.5 the whole square. Now if I see, if I try to calculate this, I know this quantity, it will be bigger, and this quantity, it will be smaller. It means our net force, it will be acting in direction of this. So my net force, it will be acting in direction of this. So I will not be exactly solving it because I think this is only calculations which you can do easily. So now we will move on to the second part of it. तो सेकेंड पार्ट में हमें क्या है, सेकेंड पार्ट में हमें इलेक्ट्रिक फील्ड इंटेंसिटी कैलकुलेट करना है एट पॉइंट सी. तो आप देखिए जो चार्ज 1 है हमारा, चार्ज 1 है जो which we have named as 1, it will be exerting force. लेकिन अगर मुझे देखिए इलेक्ट्रिक फील्ड इंटेंसिटी सी पॉइंट पे देखना है, and again I bring my test charge at point C, my test charge, it will be repelled in this direction. So I will name this as electric field due to 1 at C. Okay, it will be in this direction. it will be exactly aligned to this. It will be in this direction like this. And due to second charge, the electric field intensity at point C, it will be in this direction, because it will my test charge, which is positive, it will get attracted towards it. So it will be electric field intensity due to 2 at C. So I know this is 60 because it is an equilateral triangle. So I can easily calculate this angle. So this is a straight line which has an angle of 180. This is 60, so it means this is 120. So now if I have to calculate the electric field intensity, the resultant, by using the superposition principle, I know as this 2, E1C, electric field intensity due to 1 at C, it will be exactly equivalent to electric field intensity due to 2 at C, because magnitude wise they are same. इन दो charges का magnitude same है, and the distance of point C from these two charges, it is also same. So these two, they will be equal. So I know they will be equivalent to K times charges Q, and I know the distance, it is 0.1 whole square. So now we have such a condition at point C that one, it is acting in this direction and other is acting in this direction. So we want to calculate the resultant, and we know this angle, it is 120 degrees Celsius. 120 degree. So we know our resultant, it will be in this direction. So I can calculate my resultant. Suppose I say the resultant to be electric field intensity at C. So it will be equivalent to electric field intensity due to charge 1 at C square plus electric field intensity due to second charge at C plus 2 times the electric field intensity due to charge 1 at C, electric field intensity due to charge 2 at C into cos of angle between them. So you can calculate the magnitude from here, and you already know the direction. It will be exactly through the midpoint of this angle. So it will be acting in this direction. I will use different color to draw it. So it will be acting in this direction. So I think you can do it by yourself. So I will now try moving to a next numerical, which is also very important one. So this is our next numerical. So we are to calculate the point where electric field intensity is 0. So while you are doing this kind of sums, you need to understand one thing. See, there can be two cases. In one case, there may be two similar charges. We have two similar charges, similar in terms of polarity. We have to calculate the point where electric field intensity will be 0. So I will be discussing for these two cases together. Suppose we have such an scenario जहाँ पे दोनों charges की polarity same है. तो I tried to guess कि where the electric field intensity will be 0, whether it will be inside or it will be outside. तो अगर मुझे इलेक्ट्रिक फील्ड इंटेंसिटी देखना है तो आई नो आई हैव टू इंट्रोड्यूस माय टेस्ट चार्ज विच इज क्यू नॉट, और जैसे ही मैं अपना टेस्ट चार्ज लेके आता हूँ तो अगर मैं इस चार्ज से इंडिपेंडेंटली देखूँ तो दिस चार्ज इट विल ट्राई टू रिपेल इट इन दिस डायरेक्शन. तो if I name it as 1 and if I name it as 2, my electric field intensity due to 1, it will be in this direction, and similarly my electric field intensity due to 2, it will be in this direction, and same will be for negative charges, means when both the charges have a negative polarity, one of them it will exert force in this direction, or we can say its electric field will be in this direction, and for other it will be in this direction. ठीक है, तो टेस्ट चार्ज तो हमारा प्लस क्यू ई नॉट ही है. तो अगर मैं यहाँ पे लेके आता हूँ तो ये वाला चार्ज है जो इट विल ट्राई टू अट्रैक्ट इट. ठीक है, तो इस केस में ये इवन होगा. इट विल ट्राई टू अट्रैक्ट इट. और ये अब जब इस वजह से मैं देखूंगा टेस्ट चार्ज पे इलेक्ट्रिक फील्ड इंटेंसिटी, and now it will be getting attracted towards this side because our test charge it is positive and this is negative. तो ये है 2, तो it will be E2. और अगर अगर मान लीजिए ये तो मैंने देख लिया कि इसके अंदर कहीं भी within the charges there may be any point where electric field intensity it can be 0. पर अगर यही चीज मैं आउटसाइड देखूं तो आउटसाइड मैं मान लीजिए यहाँ अज्यूम कर सकता हूँ. सिमिलरली आई कैन अज्यूम इट ओवर दैट साइड. तो आई वांट टू फाइंड इलेक्ट्रिक फील्ड इंटेंसिटी एट दिस पॉइंट. तो मैंने अपना टेस्ट चार्ज यहाँ पे रख दिया विच इज क्यू नॉट एंड विच इज पॉजिटिव. एंड ड्यू बिकॉज ऑफ चार्ज 1 my q naught it will be repelled in this direction. So this is my E1. ठीक है, अब सेकेंड चार्ज की वजह से देखिए because of second charge this one my test charge it will again be repelled in this direction. So this is again E2. Now if you see this two uh, they are pointing away from these two charges. ठीक है, और कोई ऐसा पॉइंट नहीं होगा where this two can become zero, क्योंकि दे आर ऑलवेज गेटिंग एडेड इन टू ईच अदर. हमेशा ऐड ही होते जा रहे हैं वो. पर अगर यहाँ पे देखें तो दिस टू आर एक्टिंग इन ऑपोजिट डायरेक्शन, है ना, तो वो वेक्टर बैलेंस आउट कर देगा. तो व्हाट आई वांट टू से इज दैट व्हेन देयर आर टू सिमिलर चार्जेस द पॉइंट ऑफ जीरो इलेक्ट्रिक फील्ड इंटेंसिटी इट विल बी इनसाइड. ठीक है, एक तो ये पॉइंट हो गया हमारा. और व्हाट इज द सेकंड पॉइंट कि व्हेन द चार्जेस दे आर डिफरेंट, लाइक एक प्लस है एक नेगेटिव है या नेगेटिव है और प्लस है. तो इस केस में मान लीजिए अगर मैं यहाँ अंदर रख के देखूं अपने चार्ज को, आई एम कीपिंग आई हैव टू फाइंड इलेक्ट्रिक फील्ड इंटेंसिटी. तो आई हैव टू फाइंड ए पॉइंट वेयर इलेक्ट्रिक फील्ड इंटेंसिटी इज 0. तो मैंने एज्यूम किया वो पॉइंट इसके सेंटर में है. सेंटर में नहीं, मतलब इन दोनों के बीच में है कहीं. तो आई बॉट माई टेस्ट चार्ज. तो सपोज अगेन आई नेम दिस एज 1 एंड दिस एज 2. आई एम ओनली टॉकिंग अबाउट द टॉप केस, प्लस और नेगेटिव वाला. पहले प्लस और देन नेगेटिव. तो आई ब्रिंग माई टेस्ट चार्ज. आई bring first I see only for this positive charge, so this positive charge it will tend to repel it. So my E1 जो है due to charge 1 it will be in this direction. अब because of E2 it will be again I will bring my test charge which is Q naught which has a positive polarity. और ये नेगेटिव चार्ज है जो हमारा सेकेंड वाला, it will tend to attract it again in this direction. तो फिर से मेरा जो E2 है it will be in this direction. तो again ये देखिए दोनों vectors they are going in one single direction. At no point these two will be equal and opposite to each other. तो what I conclude from here is कि जब दो चार्ज opposite polarity के हैं, the electric field intensity, net electric field intensity, it cannot be zero within the charges. अब एक बार जल्दी से डिस्कस कर लेते हैं. सपोज आई हैव opposite polarity charges. Now I want to see that whether the electric field intensity will be zero outside. तो मैंने क्या किया, again I bought my test charge. Again I bought my test charge. तो outside मैं देख रहा हूँ अब. तो it will be Q naught of positive polarity. My Q naught because of this negative charge it will be attracted in this direction. So suppose this is my E1 electric field intensity due to charge 1. Now what will be electric field intensity due to charge 2? So again I will bring my positive charge. I will only see the effect of this charge onto my test charge. I will, for the time being, I will ignore this. So I will find out that my test charge, it will again be repelled in this direction. तो yes, a possibility है कि मेरे E1 और E2 they can become equal to each other and they can cancel out each other. So it means when the charges they are of opposite polarity, when the charges they are of opposite polarity, the point of net electric field intensity to be zero, it lies outside. तो मुझे लग रहा मैंने थोड़ा जल्दी इरेज कर दिया, सॉरी फॉर दैट. पर अगर आप, मुझे लग रहा वहाँ पे पॉज करके यू कैन अंडरस्टैंड इट अगेन इन पॉइंट, इन आई विल आल्सो ट्राई टू राइट इट इन the point as I was written for this. This was for when the two charges they are of equal polarity. The point of zero electric field intensity, it will be inside, right? So now I will discuss when the charges they are of opposite polarity. It can be either this or it can be either this. So what we discussed just now is that point of zero electric field intensity, it will be outside of two charges. ठीक है. तो based on this we will also do one numerical, so which is this. So these two are equal charges. No, by equal I means they have equal polarity, they have positive polarity, they are not equal in magnitude wise. As we have already discussed that when two charges they have equal polarity, same polarity, the point of point of electric field intensity to be zero, it will lie inside them. ठीक है. So it will be lying inside. So we know this, we have this knowledge, but वो कहाँ है we don't know. So what we do is we take any point which is at a distance x from a smaller charge. तो ये वाला distance क्या हो गया? It will be 2 minus x. तो हम मान लिया हमने इस पॉइंट पे निकालना है, तो इसे हमने 1 कह दिया और इसे हमने 2 कह दिया. नाउ सी, बिकॉज ऑफ चार्ज 1, my electric field intensity it will be in which direction at this point? अब मैं फिर वही पॉजिटिव क्यू नॉट चार्ज ले आऊंगा. माई, बिकॉज ऑफ चार्ज 1, my test charge it will be repelled in this direction, so it means this is my E1 in this direction, and because of the second charge, my test charge at this point it will be repelled in this direction, so I will name it as E2. At when I know when my net intensity it will be 0, when E1 is equals to E2. So jaldi se we will try to calculate E1. So E1 will be K times the charge Q divided by distance, so which is X. In this case X square, we have assumed it to be X. तो हमने वो point को X माना है from the smaller charge जहाँ पे net electric field intensity it will be 0. And similarly for charge 2, it will be 4Q divided by 2 minus X, the whole square. So we cancel out this, Q and Q they get cancelled out. So we have 2 minus X by X, the whole square, it is equals to 4. So it means we are left with 2 minus X by X is equals to plus minus 2. Now we have two cases. So firstly we will take 2 minus X is equals to plus 2 by X. Okay. So in this case I have 2 minus X is equals to 2X. So for this case, my x, it comes out to be, this will go this side, so it will be 3x, so it will be 2 by 3. So this is one case. And other time it will be 2 minus x by x is equals to minus 2. So my 2x minus x is equals to minus 2x. So it will go on to this side with a positive. So x, it will be negative, x, it will be equivalent to, so it will go this side, it will be minus 1 by 2, I think, if I am not wrong. Yeah. So it will be, yeah, minus 1 by 2. Yeah, minus 1 by 2. But see, this cannot be possible. X minus 1 by 2 का मतलब इस चार्ट से हमने ये डिस्टेंस को we have assumed positive in this direction. But x minus 1 by 2, it means that point is somewhere here outside. But we already discussed it cannot happen. Reason being, जो भी point आउटसाइड पे अगर हम टेस्ट चार्ज रखेंगे बिकॉज ऑफ दिस टू चार्जेस, अगर मैंने क्यू नॉट रखा तो बिकॉज ऑफ दिस चार्ज इट विल बी रिपेल्ड इन दिस डायरेक्शन बिकॉज ऑफ चार्ज 1 and again because of charge 2, my test charge, it will be repelled in this direction. So it can never make each other nullify. तो ये कभी हो नहीं सकते. तो this is not the case, so it is this. So if you have, we can also do this through a shortcut, like in competitive exam. So I need to find a distance x. तो मुझे अब दो केसेस पता लग गए. Either the charges, they can be of equal polarity like this. So I know that is the point at which net electric field is 0, it will be lying inside. And it will be at distance x from the smaller charge. It will be at a distance x from the smaller charge. So I can directly calculate it by using under root q1 by under root q1 plus q2 into L. So x is distance from smaller charge. ठीक है? And similarly, when I have two different polarity charges, it can be plus and minus or minus and plus. At that time, my distance from smaller charge, it will be equivalent to under root q1 by q1 plus, in this case, it will be minus. तो याद रखिएगा कि जब opposite charges है तो it will be minus here into L. ठीक है? So in this way you can very quickly solve such kind of problem related to zero electric field intensity. So I think it will be helpful to you, and it will also be helpful to you from a competitive point of view. Next we have another very important numerical, which is also very important from competition point of view. इसमें क्या कह रहे हैं कि इसमें we have to see the difference between electrostatic field and the gravitational field. तो एक्चुअली क्या है कि जैसे पहली फिगर में देखिए आप, सो देयर इज इलेक्ट्रिक फील्ड विच इज एक्टिंग इन अपवर्ड डायरेक्शन, और एक इलेक्ट्रॉन है हमारे पास विच इज फॉलिंग इन द डाउनवर्ड डायरेक्शन. तो अब देखिए इलेक्ट्रॉन, इट हैज ए नेगेटिव चार्ज and it is going in downward direction, so it will be attracted towards downward direction. ठीक है? फिर वो क्या कर रहे हैं कि they are reversing the direction of electric field, magnitude they are keeping it same, distance of fall they are keeping it same, बस सिर्फ डायरेक्शन रिवर्स कर रहे हैं. एंड इंस्टेड ऑफ ड्रॉपिंग ए इलेक्ट्रॉन, दे आर ड्रॉपिंग ए प्रोटॉन. ठीक है? अब पहले नेगेटिव ऊपर था, अब नेगेटिव नीचे हो गया है. And instead of negative charge now, positive charge is being attracted downside. ठीक है? तो what we have to compare in this case is, we have to see the time of fall in each case. ये तो एक चीज है, time of fall we have to see, and we have to contrast the situation with that of free fall under gravity. तो हमें देखना है कि ग्रेविटी के जब कोई बॉडी फ्रीली फॉल कर रही हो अंडर ग्रेविटी, हाउ दिस सिचुएशन इज डिफरेंट फ्रॉम दैट. ठीक है, हमें एक चीज पता है, व्हेन बॉडी इज फॉलिंग अंडर gravitational force, we know one thing, that its acceleration, it will be independent of the mass. ठीक है, ये एक हमें चीज पता है. और दूसरी चीज हमें क्या पता है, we know the charge on electron, it will be equal to charge on the proton, and it will be equivalent to 1.6 into 10 raised to power minus 19 coulomb. We know this. और फिर हमें एक चीज पता है, that is related to mass of the electron. Mass of the electron, it is 9.11 into 10 raised to power minus 31 kg. And I know the mass of the proton. Mass of the proton is 1.67 into 10 raised to power minus 27 kg. तो यहीं पे अगर हम एक चीज देखें कि which out of proton and electron is heavier, so we can easily make out that mass of proton is more than mass of electron. So this is the one thing which we know. ठीक है, और we know that when anybody will be falling in electric field which has a magnitude of this, and it is falling a distance of this much centimeter, so it will be accelerated. So there will be force due to acceleration acting onto it, and also we know that force on any body, it is equivalent to charge on that body into the electric field intensity in which it is falling, और इनका डायरेक्शन जो है वो सेम रहेगा. And as I said, that any body which will be accelerating, it will have this force onto it. ठीक है, so I will not write it in vector form. I will write it as it is. I know the acceleration, it will be this for any given particle. It can be proton or it can be electron. ठीक है, तो ये मुझे acceleration पता लग गया. Why I have calculated acceleration is because I know this कि distance covered by it will be equivalent to its initial velocity, the time to cover that distance, plus half times the acceleration and time square. ठीक है, तो I know the distance from this distance from which this body is falling. I know initially it has been given no velocity, so this term completely it will be equivalent to 0. So I am only left with 2d, so I am making it 0 and I am multiplying 2 over here, is equals to 80 square. So what? So see, I have to calculate the time of fall in each case, for in case of proton and in case of electron. So I am trying to write the generalized formulas. So after that, I can put every detail which I have, and I can calculate the time for the respective entity, either the proton or the electron. So I know that time it will be equivalent to, from this, 2d by a the under root. Okay, so I also know what my acceleration is. So when I will put the value of acceleration from here, I am plugging this acceleration into this. So I will get, it will be, so I am putting this, so it will be 2d into mass of proton or electron divided by charge on each of it, and this. So I know this. So this is the final equation. ठीक है, तो I will try to explain it again to you. So we have to calculate the time of fall in each case. एक बार whenever electron is falling and in another time whenever proton is falling. ठीक है? और distance over which they are falling it is same. वो है हमारा 1.5 सेंटीमीटर. ठीक है? और हमारी जो इलेक्ट्रिक फील्ड है that is also of uniform magnitude. It is 2 into 10 raised to power 4 न्यूटन पर कूलम दोनों केसेस में. ठीक है. जब इलेक्ट्रॉन फॉल हो रहा है तो वी हैव पॉजिटिव डाउन साइड, सो अवर इलेक्ट्रॉन इट विल बी अट्रैक्टेड टुवर्ड्स डाउनवर्ड डायरेक्शन, एंड व्हेन अवर प्रोटॉन इज फॉलोइंग वी हैव नेगेटिव डाउन साइड, सो इट विल बी मूविंग downwards proton क्योंकि it will be attracted towards positive. We know this that force on any charge it will be equivalent to the charge times the magnitude of the electric field. ठीक है. तो we already know magnitude, we know charge, it will be same for proton and electron. We can also write the force is equivalent to mass into acceleration. We know the acceleration. We can calculate the acceleration like this. It will be charge into electric field intensity divided by mass. And we also know this. So why we use this formula? Because we are knowing acceleration and we know we want to calculate the time. So we try to write time in terms of acceleration. So when we plugged this into this, we got this. So this is the final formula which we have. Now I know the values. I want you to plug them. But yeah, we can see one thing from this equation. आप देखिए हमारा जो मास है प्रोटॉन का, मास ऑफ प्रोटॉन इट इज हायर देन मास ऑफ इलेक्ट्रॉन. ठीक है. अब देखिए इस वाली इक्वेशन में अवर डी इट इज द डिस्टेंस फ्रॉम विच द एंटिटी इज फॉलिंग, वो भी सेम है. दोनों बॉडीज पे चार्ज भी सेम है एंड इलेक्ट्रिक फील्ड की इंटेंसिटी है वो दैट इज आल्सो सेम. ओनली वेरिएबल इज मास. ठीक है. तो ओनली वेरिएबल विच वी हैव इज मास. तो मास ऑफ प्रोटॉन इट इज मोर देन मास ऑफ इलेक्ट्रॉन. ठीक है. क्योंकि वो डिवाइड देखिए बाय 10 raised to power 31 हो रहा है तो इट इज ऑब्वियसली स्मॉलर, दिस इज ऑब्वियसली लार्जर. ठीक है. तो एक चीज हम देख सकते हैं यहां से सीधा कि जो टाइम फॉर फॉल ऑफ प्रोटॉन होगा इट विल बी हायर देन द टाइम ऑफ फॉल ऑफ इलेक्ट्रॉन. ठीक है. तो इसका क्या मतलब हुआ कि जो प्रोटॉन है इट विल टेक लॉन्गर टाइम टू फॉल, पर जो इलेक्ट्रॉन है इट विल टेक शॉर्टर टाइम टू फॉल. तो अगर हम वैसे इसे थोड़ा सा समझ के देखें इट मीन्स कि जो लाइटर पार्टिकल है it will fall more quickly, whereas the heavier particle it will take longer time to fall when it is in electric field. और अगर हम ग्रेविटेशनल फील्ड से कंपेयर करें, in gravitational field our fall it was independent of mass of the object which is falling. Either you take a lighter object or you take a heavier object, fall it will remain same. So this is the final thing which we have concluded from this. And yes, I can straight away you can calculate the time. I can tell you for the proton. For proton it will be 1.3 into 10 raised to power minus 7 second. And for electron it will be 2.9 into 10 raised to power minus 9 second. You can easily calculate it by putting it into this equation. So as you can see, the time of fall for proton it is more, whereas time for fall for electron it is less, and electron it is lighter in mass in comparison to proton. So with this, we will move to our next topic, which is permittivity and relative permittivity. तो आपको याद होगा when we were discussing about the forces between two charges, suppose these are the two charges, Q1, Q2, they can be of positive polarity or they can be of negative polarity. So suppose they are of positive polarity, we say that if we try to bring these two charge close to each other, they will tend to repel each other with the force, which is force on 1 due to 2. Similarly, it will also exert a force. So we wrote a magnitude of this force equivalent to K times Q1 by Q2 by distance between these two. And we never discussed what our K actually is, but we only took its value to be equivalent to this. So K, we always took equivalent to this. So it is K is equal to 9 into 10 raised to power 9 Newton per coulomb meter square. Per coulomb square meter square. So it will be Newton. So it will be K. It will be Newton coulomb square per meter square. Sorry, it will be coulomb square per meter square. Newton meter square per coulomb square. Like this. It will be like this. Yeah. So, but if we see what actually our K is, so K is equals to 1 by 4 pi epsilon. So, what is this epsilon? Epsilon, it is the permittivity. So, it is the permittivity. So, what actually permittivity means? So, permittivity means like it is a kind of quantity of a medium which will allow the charges which are kept within that medium to exert a force onto each other. और अगर permissivity का वैल्यू कम होगा, the two charges they will also exert more forces onto each other. पर अगर permissivity का वैल्यू ज्यादा है, तो two charges they will exert lesser forces onto each other. So I will write it in. अगर तो permittivity का वैल्यू है, it is higher, the forces for a medium, थोड़ा आगे जाके आपको और ज्यादा क्लियर होगा. For a medium, if value of permissivity is higher, the forces between two charges it will be lower. So this is medium 1. Now I have another medium which is medium 2. So for this medium, the permittivity it is lower, the forces it will be higher. ठीक है. So have you understood this? और अभी तक हमें सिर्फ एक ही मीडियम का परमिसिविटी पता है, and that is for the vacuum or the air. और ये जो see, so this is the reference which we take. So that is why we are representing this with epsilon naught. We always represent epsilon naught. Epsilon naught means permittivity of air और vacuum. ठीक है. और interestingly, this air or vacuum, it has the minimum value of permissivity. Minimum value of permissivity. Because they have a minimum value of permissivity, the forces exerted between two charges which are kept in vacuum or in air, they are always maximum. The forces are maximum. ठीक है. तो ये वैल्यू है इसका, इट इज इक्वलेंट टू 8.85 इंटू 10⁻⁻12 कूलम स्क्वायर पर न्यूटन मीटर स्क्वायर. So, yeah, I think we have to redefine the units. This is sorry. This is for epsilon naught because I was confusing it with the units on last slide. They were for K. So these two are different. Yeah. So these are actually the units for this. So this is the permittivity for air or vacuum. It has this value. Now see, if I see for any another material which we see very commonly in our day-to-day life, it is water. तो वाटर का जो परमिसिविटी वैल्यू है इट इज 7.12 इंटू 10⁻⁻10 कूलम स्क्वायर पर न्यूटन मीटर स्क्वायर. ठीक है, वी कैन आल्सो कैलकुलेट इट. तो फोर्स इज इक्वल्स टू 1/4 पाई एप्सिलॉन नॉट इंटू Q1 Q2 by r square. So we need to calculate unit of this. So this will go this side. So epsilon naught is equals to 1/4 pi f Q1 Q2 by r square. So we know units for this, they are coulomb. For one charge it will be coulomb, for two it will be coulomb square. और ये सारा जो फोर्स और डिस्टेंस है दे आर इन डिनोमिनेटर, so it will be Newton per meter square. So these are the units for permissivity. ठीक है, so this is the permissivity value for एयर और वैक्यूम एंड दिस इज फॉर द वाटर. और एक इंटरेस्टिंग बात देखिए कि जो परमिसिविटी ऑफ वाटर है इट इज हायर. तो फॉर वाटर आई एम राइटिंग इट लाइक दिस. सो इट इज मोर इन कंपैरिजन टू माय परमिसिविटी ऑफ एयर और वैक्यूम. तो बड़ा इजी सा वे आउट हमने निकाल लिया परमिसिविटी ऑफ एयर और वैक्यूम लिखने के लिए. वी राइट इट एज ई नॉट. तो अवर ई नॉट इट इज ऑलवेज लेस. बट अगर हम देखें जो फोर्सेस हैं हमारी वाटर में between two charges, they will always be less than the forces in vacuum और air. तो इसका क्या मतलब, मेरे पास मान लीजिए दो चार्जेस हैं. Firstly, what I am doing is I am keeping these two charges into air. तो मैंने air में रख दिया. अब ये दोनों मान लीजिए पॉजिटिव चार्जेस थे तो they will tend to repel each other. तो अब इनके बीच में जो फोर्स है वो फोर्स ऐसे करके है, फोर्स ऑन 1 ड्यू टू 2 और फोर्स, चलिए इसे ऐसे लिख देते हैं, फोर्स ऑन 2 ड्यू टू 1. आई थिंक आई विल रेज इट. तो इट इज फोर्स ऑन 2 ड्यू टू 1, इट विल बी इन दिस डायरेक्शन. और मीडियम कौन सा है, it will air. Now what I am doing is, so this was case 1. मैंने दो चार्जेस लिए उन्हें एयर में रख दिया. Now what is case 2? I am taking the same charges and instead of air I am keeping them in water. और इंटरेस्टिंगली एग्जैक्टली सेम चार्जेस हैं और दोनों के बीच में जो डिस्टेंस है वो भी एग्जैक्टली सेम है. पर अब डिफरेंस क्या है कि दे इंस्टेड ऑफ एयर दे आर इन वाटर. So, do you think the force between these two charges it will be same? No, it will not be same because now we have changed the medium and now the medium which we are selecting it has different permittivity. तो अगर water की मैं बात करूँगा, the forces on these two charges when they are in water it will be lesser. So I think you understand the concept. Now, another thing is, it is very difficult to remember all these values, you know. You cannot remember it for all the mediums, right? We can remember it for vacuum, we can remember it for air, but it is difficult to remind it for all the mediums because we have infinite number of mediums. है ना? Oils हैं, अब ऑयल्स भी तो कितने तरह के आ जाते हैं, कोई हेयर ऑयल है, कोई बॉडी ऑयल है, कोई कुकिंग ऑयल है, कोई मस्टर्ड ऑयल है. तो एवरी एवरी oil, it will have a different value of permittivity. So it will be really complex or difficult for us to remember value of permittivity for each and every one. So because of that, to overcome this, what we have done is we have defined a term which is called the relative permittivity. So what actually relative permittivity is? Relative permittivity for two mediums, it is equivalent to permittivity of that medium with respect to permittivity in air और इन वैक्यूम. ठीक है. अब देखिए हम सबसे पहले कॉमन एग्जांपल डिस्कस करते हैं फॉर एयर एंड वाटर. नाउ इफ वी see the permittivity value for air, it was 8.85 into 10 raised to power minus 12 कूलम पर न्यूटन मीटर स्क्वायर, कूलम स्क्वायर था. एंड फॉर वाटर द सिमिलर वैल्यू, permittivity value, it was 7.12 into 10 raised to power minus 10. 7.12 into 10 raised to power minus 10 coulomb square per Newton meter square. Now, if I try to calculate the relative permittivity, so I will be dividing this two. So it will come out to be 81 times. So what it means is that permittivity of water is 81 times the permittivity of air. तो what is the benefit of doing all this exercise? तो इसका सबसे जो बड़ा बेनिफिट है, हमें सिर्फ एयर का परमिटिविटी याद रखना है और हमें एक फैक्टर याद रखना है बाय विच, जिस मीडियम का हम परमिटिविटी जानना चाहते हैं, बाय दैट फैक्टर इट इज हायर फ्रॉम एयर. ठीक है. देखिए आई विल ट्राई टू एक्सप्लेन यू अगेन. सपोज आई नो परमिटिविटी ऑफ एयर and I know that by how much time permittivity of water is larger than that the permittivity of air. तो ये वो वाला फैक्टर है. तो I can easily calculate the permittivity of water, which will be 81 times the permittivity of air, which I already know. अब सेम मान लीजिए I want to calculate the permittivity of a given oil. I know its relative permittivity is 61 times. So मैंने एक रैंडम सा नंबर ले लिया, 71 times of what? Permittivity of air के. So I know this. I know the permittivity value of oil. So it is easier to remember this factor, and we already know this. So it is easier to calculate permittivity of any given material. ठीक है. अब एक बड़ा इंटरेस्टिंग सा क्वेश्चन आपके दिमाग में भी उठा होगा कि अगर मान लीजिए इट इज दैट इजियर टू कैलकुलेट द परमिटिविटी, the relative permittivity, it is that easier to calculate the permittivity of a medium from the value of relative permittivity and permittivity of air. So is it possible that can we calculate the forces which are acting between two mediums? So yes, it is very much possible. तो अब देखिए I will try to discuss a case of a medium. It has a permittivity this, and other I have air which have permittivity this. ठीक है. तो I have two charges. Say I have Q1 and I have Q2. Firstly, I kept it in the air. They are the similar charges. They have similar polarity, which tends to repel each other. I want to calculate the force which will be acting. It can be a force of repulsion. So I know the permittivity of air, it will be 1 by 4 pi epsilon naught into Q1 by Q2 divided by R square. So R square is the distance. ठीक है, तो इस फोर्स को भी हम एफ नॉट रख देते हैं बिकॉज द मीडियम इज एयर, तो एयर को हम एक स्पेशल रेस्पेक्ट दे रहे हैं। चलिए, तो नाउ व्हाट वी आर डूइंग इज वी आर कीपिंग a similar charges at a similar distance in any medium which has permittivity em, ठीक है। तो अब forces between these two charges when they are kept in this medium, it will be equivalent to 1 by 4 pi permittivity of that medium into q1 by q2 by r square, ठीक है। अब हमें दोनों केसेस के लिए फोर्सेस पता लगी। वंस वी हैव केप्ट इट इन एयर एंड अदर टाइम वी हैव केप्ट सिमिलर चार्जेस at a similar distance in a medium. Now what we are trying to do is we are trying to calculate the ratio of the forces F naught by Fm, ठीक है। तो if I will do this, मैंने इस सारी टर्म को इस सारी टर्म से डिवाइड कर दिया, so I know my epsilon m, it will go upside and I will be having epsilon naught downside, थोड़ा लग रहा है जाना पहचाना टर्म, तो epsilon m by epsilon naught, it is relative permeability। तो और देखिए ये सारी क्वांटिटी इससे नलिफाई हो गई, तो रिमाइंडर इज 1, क्योंकि ये दोनों चार्जेस दे आर सेम एंड दे आर केप्ट एट ए सेम डिस्टेंस इन बोथ द मीडियम। तो this is equal to epsilon r, which is the relative permeability. So I can say my force in medium, it is equivalent to the force in vacuum divided by relative permeability of the medium. So you understood what we have discovered from this. So we have discovered that force within any medium, it is equivalent to the force two charges it will experience when they are kept in air divided by the relative permeability of that medium. So it means अगर अब देखिए, अगर मैं कहूँ कि जो relative permeability of water है, it is 81 times that of it is 81 times means जो permittivity है water की, it is 81 times that of permittivity of air. So my relative permittivity is 81. So now the force experienced by charges in water, it will be equivalent to force experienced by them in air divided by 81. ठीक है। और सिमिलरली एक हमने छोटा सा ऑयल का एग्जांपल डिस्कस किया था। आई सेड I have a oil which has a relative permittivity of 61. So now I have two charges. Initially I kept them in air. Now I am keeping them in that oil which has a relative permittivity of, तो मैं इसे relative permittivity है जो वो 61 है for the oil, ठीक है। तो पहले मैंने दो चार्जेस को एयर में रखा, तो नाउ आई एम कीपिंग देम इन ऑयल विच हैज ए रिलेटिव परमेबिलिटी ऑफ 61. तो आई वांट टू नो व्हाट विल बी द फोर्स ऑन दिस टू चार्जेस व्हेन दे आर इन दिस ऑयल। तो आपने कहना भी इट इज सो इजी, वी नो द फोर्स which is acting between these two when they are kept in air, we know it. So it will be divided by 61, which is the permittivity of the oil. So yeah. So with this, I will say you goodbye. But surely I will be back soon with the numericals related to permittivity and relative permittivity. As I already said you, that we will be discussing it from the board perspective, and also we will be discussing it from a competitive point of exam. So till then, thank you. Keep watching. Thanks a lot.